Welcome to this Mangold tutorial about state space grid analysis in Interact. The state space grid is an analytical tool that allows researchers to visualize interactions. It displays relationships between two categorical variables that are synchronized in time, creating a graphical landscape of dyadic interactions. Simply stated, it shows all co-occurrences between two behavior classes. The state space grid is particularly effective for identifying dynamic interactions. Before starting the routine, we need to verify that the data file contains at least two class columns with data. It is also important that events with codes from the same class do not overlap in time. Let's take a look at this demo file. It contains data of two dogs roaming around in different areas, doing different things like walk, eat, drink, scratch, etc. The position of each dog is logged continuously in the class area, and the position events are entirely independent of events for the behaviors logged in the class activities. Per class, the codes are mutually exclusive, but events do overlap with codes from the other class. The subject, after all, is always in some area while showing some sort of activity. On a timeline, this data for one dog looks like this. Here, all events are displayed chronologically on a single line per code, forming a mutually exclusive string of events per class. Across classes, overlaps are displayed as they occur, with no real connection other than their position on the timeline. The very same data looks totally different when using the state space grid. To open the state space grid chart, navigate to the Analysis tab and select State Space Grid in the Dyadic section. In the upcoming dialog, we can limit the number of codes and classes, but we don't need to. In the second dialog, select the datasets to include in the analysis and confirm the selection with OK. The grid now shows all co-occurrences between the codes from the two classes currently selected in these XY sections of the state space grid window. Each dataset from our data pool is displayed in a different color. Temporarily removing certain sets from the analysis takes just a click per set. If your data file contains more than two classes, or if you want to switch the XY axis display of the current selection, you can select the required classes in these X and Y axis sections. Selecting another class pair instantly recalculates all overlaps, and the grid is automatically redrawn accordingly. What do we see? The codes from the class selected in the Y section are displayed along the Y-axis, and the codes for the other class are displayed underneath the X-axis. Sometimes, it can be helpful to first split the data into separate sets to clarify patterns between subjects or sessions. However, reorganizing data in Interact will be part of another tutorial. Whenever two codes overlap, a circle is drawn in the cell where the row and column intersect. For example, this circle here represents the period in which dog 2 is walking in the feed and water area. The bigger the circle, the longer the overlapping. Those circles are drawn randomly per cell, and to prevent occurrences from becoming invisible, circles will not be drawn smaller than 15% of the largest circle. So if there are many small circles of the same size, it does not mean that all these overlaps have indeed the same duration. If your data contains gaps, you'll notice that there are circles drawn in the first column or the bottom row. These circles represent all situations where an event was found for only one of the two classes. In this case, there is an activity eating, but no area code was logged during that time. Depending on the applied coding system, those loose entries can reveal coding errors or simply reflect gaps in between events. If gaps are allowed in our data, we can hide these occurrences by unticking the option Show Empty Codes for a cleaner view on the data. Per default, the chart displays all events, covering the full session length. The first State Space Grid tab shows the visual results, but don't worry, you do not need to count the circles manually. The Statistics Grid tab displays the numerical results for all overlaps and offers a range of different values. The pre-selected number of events shows the frequencies, whereas the Total Duration section reveals the duration of all overlaps per code pair. The duration percentage value reflects the proportion of each overlap in relation to the total duration, whereas the average duration per event is computed by dividing the total duration per code pair by the corresponding number of events. Last but not least, the average return time indicates how long it takes on average for this combination to occur again. This return time value is only available in the state space grid. The other values can also be extracted with the help of the co-occurrence filter or the segmentation routine, both in combination with the general statistics, but that is not part of this tutorial. It is also possible to limit the data in the chart using the timeline at the bottom. Dragging the start or the end time marker will reduce the number of circles, which automatically influences the numbers on the statistic tab. This is a great way to, for example, visualize the difference in behavior before and after an intervention, or between the start and the end of a task. In this case, we can visualize that for more than 7 minutes, none of the dogs wandered into the dark areas, whereas in the end, they obviously discovered it was not scary, but rather interesting in that area. If only part of the timeline is selected, we can use the play button to replay the session. We can use these plus and buttons to change the speed of the visualization and observe how the interaction evolves over time. The circle representing the first combination currently displayed per dataset has a red dashed border by default, but you can change this color right here in the toolbar. Other changes in the visualization are available too. We can influence the opacity of the circles, the color and visibility of the arrows between occurrences, show or hide the lines, and adjust their color and opacity. Even the background color of the cells can be adapted. The first grid command allows us to reposition some of the randomly drawn circles for a cleaner view. With the cell selection tool, it is possible to select single cells that are particularly interesting. Additional statistics reflecting only the data in the selected cells can be found here, at the bottom of the Measures tab. The top part of this tab shows the totals over all currently visible events. Once your grid displays the data correctly, clicking the Copy button in the toolbar will create a screenshot of the current chart, which can be pasted in the target application of your choice. The same Copy button used while the statistics grid is visible copies the available data as a tab-separated table that can be easily pasted into Excel or other target applications. In addition, the Statistics tab has an Export button that allows us to export the numbers either accumulated for all sets as shown in the grid or as separate CSV files per set. Finally, the Events tab shows the start time, end time, and duration for each combination found, along with the codes per class. Note that the original event structure is ignored, meaning that if, for example, originally 3 successive events contain the exact same code, the state space grid treats the whole period covered by those 3 events as one event instead of 3. The timing of the new events representing the overlaps is based solely on the mutual timeline, ignoring the original number of events. For more detailed instructions, refer to the Interact user manual or consult our support team. We are happy to speed up your research, so watch our other videos to learn more.